Hello, I am Ridham Patel, student of DAIICT Gandhinagar, ID 2017-01273, BTech ICT 2017 batch. This is the video related to my calculus project assigned by Professor Manish K. Gupta. First of all, before we get into anything, I am sorry for my sloppy handwriting, but I will try my best to be as much readable as possible. Now, let us get to the fundamental question. What is calculus? Calculus is the mathematical study of how things change and what their behavior is. Now, many of us students believe in the myth that calculus is a rather theoretical subject, having a very less real life importance. On the contrary, calculus provides the platform for formatting or presenting a real life problem as a mathematical model. So the topic that I selected for my calculus project is the speeding ticket. So the logic is pretty simple. The question to be solved is, suppose there are two speed checkers on a road separated by a distance of 8 kilometers. So it would look something like this. This is point A, this is point B, and the distance between them is 8 kilometers. Alright. Now, John the driver passes the first speed check with a speed of 55 km per hour. So, Vi would be 55 km per hour and passes the second speed check with a speed of 70 km per hour. So, Vf would be 70 km per hour. He crosses the distance of 8 kilometers in just a time interval of 6 minutes. So if we assume that John starts his journey from point A at time t equal to 0, then at time t equal to 6 minutes, he would have covered the 8 kilometer distance and have reached the point B. Note that the speed limit is 75 km per hour. So V limit is 75 km per hour. Okay. So the question is, does John break the law for speeding? The answer to this obvious question is yes. He does break the law. But how do we prove it mathematically or using the fundamental of calculus? For this purpose, we use the mean value theorem. The mean value theorem is one of the most fundamental theorems of calculus. We have even studied this theorem in our 11th and 12th standard. So, what does this theorem state? This theorem states that if f is continuous in a closed interval of a comma b and f is differentiable in an open interval of a comma b, then there exists a point C where a less than c less than b, such that, let me write this is quite important, f dash c would be equal to f of b minus f of a upon b minus a. So, what does this mean? By this theorem, we can say that the mean value theorem states that the instantaneous value of the derivative of the function at some point c, which is this, will be equal to the average of that function. The average is this. In other words, it states that at a specific point c on the function, the tangent at that point has the same slope as the secant line connecting the two endpoints. So let me explain it by using a graph. So this is our graph, pretty standard stuff, 2D. This is y, this is x, and this is origin. And now we will draw a function, the basic criteria of mean value theorem are two criteria. The first is that the function should be continuous, and the second is the function should be differentiable in the closed interval a comma b and open interval a comma b respectively. So we can draw any such function. I will draw a curve like this. This is continuous as well as differentiable. Now this is the point A, and by going this side we get f of a. Similarly, this is the point B, and this is f of b. Oh, sorry, this wasn't aligned. So what I did was I assigned this endpoint as a, this endpoint as b. The value at this endpoint is f of a, and the value of this endpoint is f of b. Now, what is the meaning of secant? When we join these two end points, we get a line segment which is called the secant. So joining A and B, this purple line, this line is called secant. Now the theorem states that there will be at least one point on the curve such that the tangent drawn at that point would have the same slope as this secant. So in this example we get 2 points. First point would be somewhere over here, this point roughly, and the other would be somewhere this. This is just a rough idea. So we get 2 points in this case, but the mean value theorem states that you always get at least 1 point. At least we could have taken a graph like this. Doesn't matter, you draw a secant, you get a tangent at some point, at some arbitrary point C, and you get the equal slopes of these two. So that doesn't matter. Alright, this is just for reference. This is the main one. So the slope of this tangent as well as this tangent would be equivalent to the slope of this secant. Okay, so this is the geometrical or graphical meaning of the mean value theorem. Now going back to the question described before, this was the question described before. We calculate the average speed of John. So what would be the average speed of John? V average would be equal to, let me use some other pencil or pen. Yeah, so V average would be equal to delta D upon delta T. Pretty basic stuff. This delta D is the change in distance upon the time interval in which this change occurred. So in our case it is 8 kilometer upon. Now the time described in this question is in minutes, but we are talking in terms of kilometers, hours and kilometer per hour. So we would convert this time in hours, okay, divided by 60. So this would be 80 kilometer per hour. Now 80 kilometer per hour is definitely a bigger number than 75 kilometer per hour, which was our V limit, that is the speed limit. Okay, so clearly the average speed is greater than the speed limit. Now as described before, there will come an instant when the instantaneous speed will be the same as the average speed throughout that path. So clearly our driver John definitely breaks the law. We can infer that he drives at least at some instant at the speed of 80 km per hour. This same principle can be applied in traffic regulation rules, so we see that calculus can indeed be useful to solve a real life problem. Thank you for your time. Do check out the Google site that I have created on the same topic. You would get more references and more information in that. The link for the same is provided in the description box below. Thank you.